So the topic is static member. Static members are allocated memory as soon as class gets loaded in the memory. They are not associated with the instance because they are allocated memory even before any instance gets created. So they are not associated with the instance. Since they are not associated with the instance, they have only one copy in the memory, irrespective of number of instances created. So you may have hundreds of instances, but only one copy of static in the memory. They can be accessed by class name. Now you know that instance members are accessed always with the help of reference, like s1 dot student name or s2 dot student name, like that. But static members are the ones who can be accessed by class name. They are also called as class variables because they are allocated memory as soon as class gets loaded. They are called as class variables. So in Java, either you say static member or class variable. Both are same. And then static member function is used to access private static member. Now, first of all, let's see what is the need of static member in the object-oriented programming. So we have an example of account class here. Class account with ID, name, type, balance, all are instance members. So what do you mean by instance members? These are the members which are allocated memory only after an instance or object gets created. So ID, name, type, balance are instance members. We have setters and getters. And then here we are creating one object. Now, since the class name is account, and when you create object, that means it's like you got first customer for a bank. Okay, so you assign some account ID, or maybe you generate some account ID for that customer. Then that customer's name you register, which type of account he would like to or she would like to open, that is saving, and with what balance he or she would like to open the account. So that is all for one customer. And like that, when you create, let's say 20, 25 objects like that, so you can say 20 or 25 customers we have for a bank. Okay, so account A1 is equal to new account. Let's see. So we have an object of account. Let's say that object is created or allocated memory at 2000 address. And then we have ID, name, type, and balance are the instance members. So as soon as object gets created, ID, name, type, and balance. Type and balance are the instance members. Okay, A1 is a reference which will refer to that object. And then we have called setter methods, that is ID1, name, ABC, type, saving, and balance 30,000. So 1 ABC, 1 ABC, saving, let's write in a shortcut, savings, and 30,000. Okay, so this is about first customer. And then we have one more object. Let's say we have one more customer we have for a bank. So that's another object. Let's say it is stored at 3000 address. Again, you have ID, name, type, and balance different for different customer. Balance. So all these members are allocated memory. Notice that all these members are allocated memory as soon as object is created. And that's why these members are called as instance members. A2. And then you're called setter methods here to XYZ current and 80,000. To XYZ current and 80,000. 80,000. Right? So you have two customers for a bank. One, ABC saving 30,000. Two, XYZ current 80,000. Okay. And now, suppose our system works fine. And now we realize that one more member is required in the class. In the class, we have ID, name, type, balance, and one more member is required. Let's say private int rate. Private int rate is equal to, let's say, or private int rate. Okay, not is equal to private int rate. So we realize that this member is required along with ID, name, type, balance. Now, if we suppose add rate, if we suppose add this rate member in the class, what is going to happen here? Here, you will have one more member. I'm writing here rate, isn't it? Because the way you have declared it is instance member. So if you do that, now what will happen? There will be one more member in the object. So we might say, what is the difference in that? What makes it difference? One more member, okay. But notice that the member is rate, the rate of interest, and rate of interest should be common for all the customers. Rate of interest should be common for all the customers. It shouldn't be different for different customer. Okay, that doesn't make any sense. So because of that, we will not declare rate as instance member. What is our requirement here? Our requirement is rate should have only one copy in the memory, and that should be shared by all the customers. I repeat, rate should not have separate copies. Rate should have only one copy in the memory, and that should be shared by all the customers or all the objects of account. Since you have this requirement that rate should have only one copy in the memory, irrespective of number of objects of account class are created. So you have to make it static. You have to make it static. Now, when you make rate as static, what difference does it create? When you make rate as static, rate won't be a part of this object. Not here. Not here. Rather, rate will be stored separately. Where exactly? We'll discuss in the discussion called as JVM architecture. But at present, you understand that rate won't be a part of object. rate will be stored somewhere separately, and that location will be common for all the objects. Okay, so let's say the location is here. Notice that rate is not associated with any object, or rate is not associated with any instance. It has got only one copy in the memory. So now, since it is going to have only one copy in the memory, we would like to initialize. Let's say bank's policies, bank would like to give rate of interest as 9. So why to accept from user? Better initialize. So when you initialize, it is 9. And notice that it has got only one copy in the memory shared by all the objects. Okay, so that is the concept of static. Static members are allocated memory as soon as class gets loaded. They are not associated with the instance. Since they are not associated with the instance, they have only one copy in the memory. Only one copy in the memory, irrespective of number of instances created. So in our case, there are two instances or two objects are created, but irrespective of that, we have only one copy of rate in the memory, and that copy will be shared by all the objects. Okay, and then in the note, it is written, they can be accessed by class name. They can be accessed by class name. No need to say, as far as our code is concerned, no need to say a1.rate or a2.rate. You can say account.rate. But wait, if you try to say here system dot out dot println account dot rate, this is logically correct that you are accessing static member with the class name. No need to access static member with the reference because it has got only one copy in the memory. So whether you say a1.rate or a2.rate doesn't make any difference. It is the same rate you are accessing. So account.rate. Okay. But now there's one problem here. The problem is this account class has got private member rate, and which you are trying to access from another class. As you know, private members are accessed only in the same class. So even though logically this statement is correct, syntactically this statement is wrong. You can't access rate which is private in the account outside the account class. So what can be done now? We have to define method. Like all these members, they are private, isn't it? So are we accessing these private members directly in the main? No, we are accessing indirectly with the help of setters and getters. So let's say we will also write setter and getter for rate. But hold on, we have initialized this rate as 9. So why to define setter method? So setter method is not required at all. We don't want user to change, or we don't want anybody to change the rate once we initialize. So let's not provide setter method, but getter method is required. So let us define that getter method. Public int get rate. Public int get rate. Return rate. Now this method we can call from main. But hold on, this method is non-static. And for accessing non-static method, you have to you have to use either A1 or A2. Okay. In order to access this get rate, which is non-static method, you have to use either A1 or A2. So just now we said that in order to access rate, you don't have to use reference. And now when we are saying in order to access get rate, which is non-static, we must use instance. So that means now our requirement is somehow we want to define such a method which can be accessed without reference. Or in other words, the method which we can access using the class name. So can we define such a method which can be accessed with the class name without reference name? Yes, of course. And that is static method. So get rate should be static. Get rate should be static. And that static method is public. It is returning rate, which is private. And now main function will say account dot get rate. I mean, main function will call get rate with the help of class name. So private static member obviously cannot be accessed directly outside the class. How will you make it possible? By providing public static method. So this public static method outside the class can be accessed as class name dot method. So when you say account dot get rate will return you rate. Okay, so this statement, static member function is used to access private static member is true. Static member function is used to access private static member is true. Now, one more requirement is there here. Since rate we have initialized to 9 because we don't want anybody to change. We have also not provided setter method so that nobody should call set rate and try to change it. One more precaution we can take if we want to ensure that rate shouldn't be changed once initialized. So we will also make it final. Final means constant in Java. Once initialized, you cannot change. If you try to change, if any part of the program tries to change it, that part of the program will get error. Final is constant, cannot be changed. So this final and static combination is quite common in Java. You make it static so that it should have only one copy in the memory and it can be accessed with the class name which you initialize. And since you initialize, you don't want anybody to change that. So you make it final. Final means constant. Okay, so that's it. This is what about static we discussed. Thank you.